Let's now do a similar problem, superposition in the frequency domain, but this time we're going to use different frequencies. So this circuit looks similar, except now we've got a DC source here. So its frequency is 0, and this source is 10. So still the same method to start off with. We will write each in the frequency domain. When you use the omega equals 0, you can write it in the frequency domain. There's nothing wrong with that. That would give us our 6-volt source. And now our Z sub C, which is 1 over J omega C, our omega here is 0. So 1 over 0 is going to give us an infinite impedance. So it's just going to be an open. And because of superposition, we zero out our voltage source. Now, we could use phasors like we just did, or we could more simply use just the fact that this is DC, so we're in DC steady state, so capacitors are opens and inductors are shorts. Either way, we get the same answer. We get the circuit. Where's their current flowing here? Well, it would flow out the more positive, and then it's stuck. So it can't flow anywhere. So that means our current is going to be 0. And if our current is 0, that means that we know that the voltage across here, by Ohm's law, has to be 0, because the voltage is equal to I times R. So if I is 0, the voltage is 0. And that means that if there's 6 volts between this point and this point, there's got to be 6 volts between this point and this point. They're connected by wires and there's no voltage dropped here, which means there's 6 volts between this point and this point, which means our answer is 6. And that's our first partial answer. So I'll write that V sub 1. Let's now draw it with our 12 cosine of source on. So now our 6-volt source is shorted. I'll move that 3 ohms over on the left just to balance things out. The impedance of our capacitor, we already figured out on our left, it's minus J. And now once again, we get a voltage divider. Now it's not quite as simple to figure out what that voltage is. It's still a voltage divider, right? It's still, we've got a 12-volt source, 2 impedances in series, and we want to find the voltage across this 3. So by the voltage divider rule, it's equal to the one we want to find it across, the 3 divided by the sum. And throw that in the calculator, and we get 11.4 at an angle of 18 degrees. That's our second partial. And we cannot add these together because they're at different frequencies. So the only thing we can do is to convert them back into time domain. A phasor of 6 volts at 0 frequency is just 6. And here, our phasor of 11.4 at a frequency of 10 is times cosine 10t plus 18 degrees. So now we can add these things together to find our total voltage, which is 6 plus 11.4 cosine of 10t plus 18 degrees. So in summary, the big difference is if you have 2 phasors at the same frequency, you can add them. If the 2 phasors are at different frequencies, you can't add them. The best you can do is convert them back in the time domain and then add them in the time domain. That's why we just had one component over here with the same frequencies, and we had 2 different things being added when we had different frequencies.